All right, today we have an expert in a very interesting new field of laser weaponry, which has been part of science fiction novels and movies from H.G. Wells to George Lucas. But the military struggled to make them work as they were more of a dream of military researchers than a reality. So today we're talking to Mark Neice, who is the CEO of Direct Energy Consultants, which provides technology and research consultation in the field of directed energy weapon systems. He's a retired colonel serving 25 years in the United States Air Force, where he also headed up the Air Force Research Laboratory's Laser Division. Overall, he served a total of 37 years with the Air Force. Hi, Mark. So before we get into our discussion, we want to lay the groundwork with a few short answer questions. First, please tell us, what are directed energy weapons?
Well, Leonard, thank you for having me here, and Nick for inviting me to this. So, a directed energy weapon system is either a high power laser system. We're talking about kilowatt to megawatt class laser systems to create anti-material effects, and or high power radio frequency weapon systems that disrupt the electronics of an inbound system, such as to disable that and drop it to the ground.
And you kind of mentioned it there, but beyond that, what's kind of like the primary differences between the two that if someone was looking at them both, be like, okay, that's that and that's that kind of thing?
So a laser system is focused light through the atmosphere, and we look for a spot size on a target at range. Let's say anywhere from the size of a quarter to the size of a beach ball, depending upon that various range. And it's intended to create a thermal effect. For the high power RF activities, it is high power radio frequency that transmits in a broad spectrum, creating kind of a larger cone of activity, and it disrupts the electronics either on the front side or the back side of a what we call an inbound target, and causes that disruption to disable the vehicle and or force it to send a signal that will turn it around, send it back to its owner.
And today, are they actually being used in battlefields right now?
We do have both laser weapon systems and high power RF systems that are deployed outside of the CONUS. We do a lot of testing and training activity inside the continental United States, but we do have systems that are deployed in the Central Command area of responsibility, in the AFRICOM area, and in the European Command. So we have systems deployed to all three of those areas right now, going through what we call long-term demonstration trials to look at the feasibility of how these systems operate in the hands of sailors, soldiers, and airmen in those various environmental conditions.
All right, one more opening question, Mark. In I'm not sure if you saw this, but in targeting these drones, there was a report that the percentage of Russian casualties in Ukraine now attributed to drones is 80% of the Russians who are killed or wounded by drones, and 65% of their tanks. Can you believe this? I mean, it's always usually artillery, right?
Well,
80% they say.
certainly, I would say that yes, those numbers, they might be a little high from what I would expect, but the weaponization of UAV systems, drones, particularly very inexpensive, cheap drones that you can put, a low power explosive system, grenades, those kind of things on, and use that as a direct attack vehicle is becoming far more prevalent. We see a lot of that in Ukraine. We see a lot of that in Iraq and Syria. We certainly witnessed those type of activities on the Iranian attack in Israel. And so weaponizing those UAS systems has become increasingly more significant. We have not experienced that in the United States yet.
Yeah, very interesting. So we're going to get into the question portion now. We're going to split it into two parts because we want to try and keep it clear. Obviously, we're going to talk about laser systems first, and then we'll move into high power radio frequency systems. But let's start. We'd like to hear more about your background with your work, specifically with your work with directed energy weaponry. What were the systems like when you first started your work? I'm assuming this was during your time at the Air Force's Research Laboratories Laser Division.
Well, certainly. So I started my foray into directed energy when I was part of the Airborne Laser Program Office in the mid to late 90s, where we put a megawatt class chemical laser on board a 747 and put a large meter class aperture on the nose of that 747, flew it, and engaged airborne targets, missile threats, such as what was experienced during the Desert Storm, Desert Shield timeframe, and negated those targets in the air. That was my entry into that. From that, I went to, as you said, to the Air Force Research Laboratory and ran the laser division there for a couple of years. At the time, we were still largely focused on chemical lasers because that's where the power was. We could get the power out of the systems that was necessary for having a military effect. At the same time, we started a foray into electric lasers, solid state lasers, first looking at slab technology and then growing off the telecom business, looking at the opportunity to increase the power through fiber lasers. And so, in my time at the research lab, we started that. When I retired from the research lab and recycled back into government service, I worked for the High Energy Laser Joint Technology Office, and we had two large programs there, the Joint High Power Solid State Laser System, which was the first 100 kilowatt class solid state laser demonstrated in the mid 2000 timeframe. And we followed that up with a program we called the Robust Electric Laser Initiative, largely focused on fiber laser activity. And we just demonstrated 50 to 70 kilowatt systems in the mid 2010s timeframe. And so it's a progression, and we have now migrated away from what I would say the chemical laser systems that we were familiar with, and everything that we put our focus in now is on electric laser systems.
Yeah, we read about this fiber lasers and how they amplify and focus light from hundreds of strands into a single beam. So that sounds like it. That's the I don't want to say the current technology, but that's where it's evolved to at this point, huh?
That is where the current technology is, and it's evolving. We have now, delivered systems that are multi-kilowatt, 10, 15, 20 kilowatt systems that we use for counter UAS solutions, counter UAV solutions. We've scaled that up to several hundred kilowatts, which now give us a counter missile capability. And as we get into the megawatt class, it pretty much takes out all of the missile threats that we would see at ranges that are significant to the operational warfighter.
And what's prompted? I mean, it's obvious, but we want to hear it anyhow. What's prompted the strong interest in laser weaponry in recent years? I mean, as you said, it's been around a while, but it's in hyperdrive now. They're trying to get it going, right? Faster than
It
yeah.
is in hyperdrive, and part of it is that we can leverage the commercial industrial base to help develop the laser sources, the high efficiency, high brightness laser sources that we need for defense applications are also applicable to the manufacturing world and creating, doing all the precision cutting and welding that is necessary for manufacturing. So we leverage heavily off of that industry. The other part is that currently, when we use kinetic effectors against some of these targets that are being provided to us by the Houthis and the Iranians and other folks, we're on the backside of the cost curve. So it costs us more to fire our defensive systems than it does for them to provide those targets to us. We want to reverse that cost curve aspect with a directed energy system because, quite frankly, for less than a pint of diesel fuel, we can engage a target for several seconds at the appropriate range and take it out. And we can cause either a burst effect. We can heat up the high explosives in it and disable it that way. We can destroy the aerodynamic effects of an airborne system. If you take one of the propellers off a quadcopter, it doesn't operate very well. If you influence the fins on a missile system as it's in flight, or the nose cone of a missile system as it's in flight, it doesn't do very well aerodynamically. And so what we're trying to do is limit the number of kinetic effectors that we need to put in place, save those for the really hard targets, and take out the soft targets, the easy targets, with our directed energy systems.
Um, I'm curious about how common lasers right now are being used because a lot of, I mean, recently, the last month, I've seen like the Houthis have shot or sent like 5 different drone attacks on aircraft carriers. And earlier this year, there was a drone attack in Jordan that was publicized a lot by a lot of people would probably know about it because it is an election year and it was used pretty politically, where we lost 3 soldiers. And I think in May this year, the U.S. military in the Middle East used lasers to shoot down UAWs. And I'm just curious how common right now lasers are being used to eliminate drones, whether it's the U.S. or other nations that are using lasers or not.
So we have multiple systems that are built, demonstrated, and deployed, and the actual numbers we won't go into. But there are sites, as I said, both within the CENTCOM area of responsibility, AFRICOM, and European Command, where we have demonstrated those capabilities. Sometimes we launch targets of our own just to keep the systems operating. And sometimes our adversaries are more than willing to provide us with a supply of targets for us to engage both with kinetic and non-kinetic effectors. We've been pretty successful, and we see a lot of news stories about the effects of our kinetic effectors in that. Again, we're on the backside of the cost equation there, but we do have non-kinetic effectors, the DE systems that are overseas engaging targets and are being quite successful.
And out of curiosity, I mean, you don't have to get too into specifics, but I'd assume the U.S. is kind of the most further developed with laser weaponry. Is a lot of other nations kind of developing it further? You've mentioned some in Europe, and like is China kind of developing it too? If you know, like Russia, is a lot of these other nations, or is it really mainly a U.S. kind of leading force of?
So it's certainly a technology that the U.S. is one of our world leaders in. We collaborate with a number of our allies. We strongly collaborate with the United Kingdom, and you've seen a number of articles come out of the United Kingdom on their various laser systems, Dragonfire, their Wolfhound system, and some other capabilities that they're leveraging. We work closely with our NATO allies, so France, Turkey, Germany, a number of those countries have developed capabilities. And then we're also working with our Pacific partners in Australia, Japan, South Korea to develop these technologies and create certain capabilities. Our adversaries are not sitting on their hands. And so the Chinese have a robust directed energy research activity going on. The Russians are very skilled and talented in directed energy and lasers. For many years after the fall of the Cold War, we collaborated with the Russians on their activity, and I will tell you, I've been there and I've been very impressed with their capabilities. Today, currently, we don't do collaboration with the Russians. But we're aware of activity that is there with both Russia and China, um, and and their research activities and their development of the technology.
We're curious on how the U.S. military, I mean, currently it's deployed, I would assume, with the Army, obviously, but the Navy must be using it, as we say, we were talking about it in the Red Sea against the Houthis. So is it primarily the Navy and Army doing it? And at what level in the Army? Is it down to platoon level, or is that kind of getting worked out right now? Trying to figure
Those
out.
those things are still being worked out. It is for the Army. It's being developed as a platoon level weapon system capability. Typically, you will have multiple systems within a platoon that they would be operating and defending a designated area, forward operating base, and or some level of mobility as they move out. And so the systems tend to be put onto um, vehicles that the Army operates. We have systems on a Striker. We have systems on a Hemet. We have systems on ATVs. And so it all depends upon the size of the area that you're trying to protect to you know what the capability needs to be. But it is developed as a platoon level activity. So the Army is kind of leading that through the Rapid Capabilities and Critical Technology Office to push that forward faster. We have systems that are deployed on Navy ships. We won't go into in details of locations, but they are deployed. They have demonstrated. The one that was famously done was the Navy's first laser air weapon system, LAWS, that was deployed on the USS Ponce, which was a resupply ship in the Persian Gulf, and operated for a number of years in that area, gathering operating data and those kind of things. What was interesting is that the Navy did kind of a good PR piece. They they put it on the Ponce. They put it in the Persian Gulf. They put some airborne targets up and took videos of those becoming flaming wreckage. They put some topside munitions on a barge. They engaged those and popped them off. They put it on a video, put it on YouTube, and the Ponce was given a pretty wide berth in the Persian Gulf for the years that it operated there, which was kind of a unique way of advertising to everyone. These capabilities are out there. You probably don't want to get too close.
Yeah,
Um, you
well,
go.
let me ask. So the Striker, it's interesting what they've done. As they upgraded the Striker with its own capabilities, and we saw another system called the Vampire, which they said has been sent to Ukraine. Which both are, I really, and when you think about platoon level, now if they're hit by a swarm, one vehicle's not going to do it, right? So they're going to have to they're going to have to work with the other platoons, right, to stop them. But it's really their only defense. I mean, other than trying to shoot their weapons at it, right?
That is correct. And
Yeah.
so the and you good point, Leonard. A laser weapon system is defensive, point to point to point. So it's going to engage a single target at any given time. We'll get into the swarm effects when we talk about the high power RF technology, but currently a laser system engages a single target. We can track multiple targets, and so the engagement for multiple targets is just the gimbal time, the swivel time from target to target, and then engage it for a couple of seconds, swing to the next target and engage it.
In terms of developing laser weapons, what are some of the challenges that come with the development of those?
So the biggest challenge I will say from a laser weapon system capability is the atmospheric propagation. As I said before, we use lasers for cutting and welding, but their focal length is millimeters. Now we're trying to project that out kilometers and to create a spot size, the size of a $50 on a target at respective ranges. And so we have to compensate for the atmosphere, which is going to distort that light beam. We don't want it to be a flashlight, which just, puts the beam out. So we actually pre-distort the beam and allow the atmosphere to provide some of that focusing factor so as to create the spot size on the target at the respective range. The other
Okay,
piece,
that's impressive,
yeah,
right? I mean,
this is,
so if it's raining, Mark, is it that it doesn't work at all, I'm assuming, or does it?
you would be incorrect. It
Ah,
it it affects the range that you can operate it, but it does not render it useless. So we look at things like moisture content in the air, dust particles, blowing dust, those kind of things. There's a great video, Leonard, that would be cool for you to see of the cadets at West Point operating a laser last year in a snowstorm, and they
Oh.
were firing across a kilometer range on a parking lot up at West Point in a snowstorm, and watching the light speckle off the snowflakes. But we were able to collect data at range to show that even in a snowstorm like that, we can still cause a laser effect.
so as a operator or as a commander of that, you've got to let it obviously let this threat come closer and closer because it's limited. Huh? So it's a little bit. There's a little gut check there, right?
There is a gut check that goes
Yeah.
with that because, and what we're trying to do, well, not trying, what we are doing right now is tying in the effectiveness of our directed energy weapon systems capability into the standard meteorological data that you would have, existing at a forward operating location or forward operating base. So our Met guys are out there, meteorological guys are out there collecting data, 6, 8 times a day, every couple of hours. And so knowing that and feeding that back into the modeling capabilities of the weapon system and the autonomy of the weapon system allows you to now know, okay, so today's a good day. Today's maybe not such a good day. And there may be times when, as you said, the commanders, it all depends on his pucker factor.
Yeah.
How close are you willing to let that thing get in? The closer it gets, the shorter the engagement time because you're putting the same amount of energy out there with a laser weapon system. But there's a pucker factor at which you say, okay, close enough. Um, as they said in Top Gun, too close for missiles, I'm switching to guns.
So besides the laser beam control, um, another factor is power. And so I'm thinking about it on a Striker. I'm assuming you have the power. You got an engine there, ship, same thing. So it's kind of under control. I mean, the power is obviously a big concern because there's no lack of ammunition as long as you got power, right?
As long as you have a power source, you have a weapons engagement capability. Now, what we do is we have battery storage, oftentimes that we'll put in conjunction with the weapon system. On some of the smaller mobile platforms, it becomes a little more challenging, and you'd like to have it always be direct drive, but what often do is we'll store up energy in a battery capacitor, and then have high discharge rates to do that, and then continue to recharge those batteries as we're using it for the engagements. And typically, we're looking at somewhere between a 30 to 60-second magazine on the laser weapon system is kind of the inertial design that we look at, and each of those engagements is only going to be a couple of seconds. So you're looking at anywhere from 10 to 20 standard engagements before you would kind of deplete your initial magazine and then have to go to a recharge rate. And you said power. The bigger challenge for us is thermal management. Because with a laser weapon system, we're running about 30% efficiency right now. So that means for 100 kilowatts of laser, I need 300 kilowatts of energy. And that's 200 kilowatts of waste heat that we have to take care of. And so creating the opportunity to manage that waste heat in an effective way and then also recharge the batteries is kind of so we said beam control is a principal challenge for us. Thermal management is a big challenge for us as well with our
Yeah,
laser weapon systems.
completely makes sense. Yeah, I didn't even, of course, I was thinking that. I was also thinking the thermal signature that's shown on each one has got to be dissipated in some way. Otherwise, it'll attract the attention of enemies, right?
It can certainly attract attention. That is a
Yeah.
large heat signature trying to dissipate hundreds of kilowatts worth of thermal energy.
All right, one more challenge that I know the answer to, but there's always talk about putting mirrored surfaces on your drones to try and deflect. That's kind of a myth, right?
So we love that, and there are any number of um, defensive capabilities against lasers that people will claim, adhesives that they can put on, or paint schemes, or polished surfaces, or all of that. We test all of that. We know what the effect is. Um, it
It's
doesn't.
minimal, huh? Yeah.
Yeah, we go through. It can delay an effect, but it doesn't stop the effect.
Yeah, so let's talk about the other direct energy weapon or directed energy weapon that's also being worked on. High power RF, also radio frequency. Um, and also, can you explain to the viewers the difference between the names of high powered radio frequency and high powered microwave system and basically what it is and that sort of stuff?
So high power RF is the preferred technology because that's what it is a high power radio frequency. High power microwave is one of the designations we use within the Department of Defense. They're synonymous with one another, and so you'll see them used back and forth. High power RF is basically we're talking now about megawatts to gigawatts of power energy that goes out. Unlike a laser system, they're more challenging to focus, and so the antenna design becomes very important for us, so as to create a barrier or a wall of energy that these things would come into. They're very effective for short range counter UAV defensive capabilities because it kind of puts up a wall, and you'll see videos, and you can go online and look where you'll have a swarm of UAVs coming in to an area, and they hit that barrier, and they all drop. And that's kind of the our defense against swarms is going to be a combination of RF systems, laser systems, and kinetic effectors. It's a layered defense type of activity, but certainly you want to be able to have and they all have their individual range points at which they're most effective from an engagement standpoint. The again, the RF is looking at disruption of the electronic signal internal to the target, and we're trying basically to cause either a front door or a back door effect in there. Doesn't always require a intimate knowledge of the electronics that we see in a system, because if there's a channel for us to actively um, target for causing that electronic disruption, that's what we're looking at to create that. And like I said, it can come in, either on the front end side, which takes a little bit of intelligence to understand, or a backdoor deleterious effect that just comes as part of the capability.
So initially, I think back to I think it was called the electromagnetic pulse from nuclear weapons. It kind of reminds me of this, where they realized during testing, I think especially, that they were wiping out the electricity grid in nearby areas. So did it evolve from that? I mean, what spurred this development of this? I mean, it's such a unique weapon in so many ways, and like a lot of this, what we're talking about drones, but the truth is, missiles, it could operate in the same way to like you said before, put them off course.
Correct. And so, Leonard, you started out correct. EMP was one of those effects that we determined from our nuclear weapons testing. We did some nuclear weapons testing over the Marshall Islands, and we caused an EMP effect, and it knocked out some of the electrical capability in the Hawaiian Islands. We went, oh,
Uh-huh.
that's interesting.
Yeah.
And we did some more research on it. And we said, wow, so we can create this effect, electromagnetic effect, with a high altitude um, detonation of a nuclear device and create, and take out the infrastructure, the electronical infrastructure. So now we said, well, that's interesting. Now, how do we control that? Because, we really don't want to be using nuclear weapons just to create the electronic effect. And so a lot of research has gone into creating those opportunities and capabilities, understanding how to package that into a sizable effort and create that EMP effect with a non-nuclear um, activity. And so that's where the high power RF activity has evolved from. We now see that we can do that fairly well. We can create that. They are power hungry systems. So before we were talking about laser systems being, roughly 30% efficient. Well, now we're talking about maybe 15 to 20% efficiency, power conversion into into electrons. And so again, we have to deal with um, propagating that through the atmosphere, the RF through the atmosphere. We have to have a large enough power source to be able to create the effect, and we have to have a thermal management system that can absorb the excess energy and convert that back into something. Maybe it's useful. Maybe we can reuse it. Maybe we just throw it overboard, depending upon what our physical environment is.
You mentioned a few of the challenges of propagation, same as a laser, is the thermal management. Are there other challenges in development of this? I mean, and as you just said, the industrial base it's not as many uh, civilian applications, let's call them, or commercial applications. What other challenges are there in order to create an effective system for the battlefield?
For us right now, the big challenges are power generation and efficiency. Creating those efficiency, getting those efficiency numbers. So uh, if you can increase the efficiency of a system by say 10%, you may cut the thermal management requirement in half for that system, depending upon your duty cycles and that. So there's a big impact there. If you can improve the efficiency, you can cut down on the thermal management, and now that reduces the overall size of the system that's required.
In both these systems, I would assume this is technology in action. They're getting smaller. I'm assuming the laser systems are getting smaller. It's all part of advancements, right, in technology. And that's a huge advantage. I know some of those ones. You talk about the 747. I saw that thing was 12,000 pounds that they somehow shoehorned into a 747. That
It
initial
was
system.
more like 120,000
Yeah,
pounds.
it was some crazy amount, right? So
Yeah.
so it's it's advancing not at light speed, but it's they're getting smaller and stronger and like you said, with little less thermal exposure too.
Yeah, the technology is evolving. We're getting better at it. Um, and the other big driver that we really look at is the cost. So, for a directed energy system right now, the acquisition cost of shipset one is pretty strong. It's pretty high. Um, and we haven't gotten into a manufacturing run yet for either a high power laser system or a high power RF system that allows us to have some continuity of production of manufacturing that would allow us to bring those costs down. So, like I said, the operating cost is pretty inexpensive. We're talking about less than a pint of diesel fuel for either system to create the effect. The challenge for us now is we've got to overcome that hurdle of the acquisition cost, and because we don't have a great number of systems, we don't have the logistical database to understand what it takes to support the systems in the field, in the environments that we expose them to, and to create the supply chain that's necessary to keep them running. We know how to do that with bullets and bombs and missiles. Man, we've been doing that for 100 years. And so that supply chain piece is kind of well understood. We don't always exercise it the way we should, but so the supply chain challenges that we have with direct energy systems are emerging, and that's going to be the next bump that we have to get over. Is as we get into manufacturing and rapid deployment, multiple deployments of these systems, how do we sustain them? Can we sustain them in the field, or do we have to send them back to a depot for repair? All of that type of data set is necessary for us to understand how best to operate these things.
Well, tied to that, you make me think of one more thing, command and control. How are you tying in all these systems as you think about a swarm coming in? How are you directing your your disparate weapon systems? Who's hitting what, right? And somehow they figured it out when Israel got attacked, and the French and the British and the Americans and the Israelis were all stopping it, right? So
Yeah.
it's doable, but this is another challenge when you're on a ship in the Red Sea and they're all coming at you, right?
So we have integrated directed energy capabilities within the command and control capabilities on our Navy ships. We've integrated that command and control capability within the Army's C2 nodes for defense and protection. We are working to integrate that right now within the Air Force for airspace protection and those kind of things. All that, as you pointed out, Leonard, takes time. It is a challenge. Those are the things that we have to work on to get us to a point where now we have an operational capability that is, selectable, where the platoon leader can look and say, today, take out, this sector is going to be my laser protection, and this sector is going to be my air defenders, my kinetic effectors, and those kind of things.
I mean, you mentioned the future and with time. So, I mean, without getting too classified, like, what's the kind of future ahead of directed energy weapons? Like, where you would like it to be, where everyone's kind of pushing for it to be, and what needs to be developed in that aspect, with which you've mentioned, obviously.
So I'm very optimistic that in the current budget activities that we see going on for the Department of Defense, we will see directed energy systems go into production within what we call the 5-year defense plan, the FIDEP. And we'll see those systems being integrated and deployed both with our soldiers and sailors. It's going to take a little bit longer to integrate that within the Air Force structure, just because we've got to figure out now how do we add that layer of the airborne environment in there.
Yeah.
But and that's by bringing those things into production, we will learn a lot of the challenges associated with the supply chain. Every time we introduce a new weapon system, we always run into supply chain challenges because we don't really understand what's going to break, how often it's going to break, what's the mean time between failure, between critical failures, the mean time to repair, all that. That's all data that will be collected as we deploy these systems in numbers, in production numbers, and start creating the industrial base and the supply chain necessary to support it. But I think you're going to see that within the next 5 years, you're going to see a rapid development and deployment of these directed energy capabilities.
In terms of, we mentioned laser and high power RF. With directed energy weapons, what's kind is those like the only two, or is there other stuff? I mean, unless it's too classified being developed, is there other stuff in the directed energy weaponry field that's kind of prominent?
So in the directed energy, the other piece part that we look at is what we call particle beam acceleration. Um, that is a technology that is largely being researched and still kind of at a lower technology readiness level. We've done some demonstrations with that. There was a lot of focus on that activity during the SDIO days. Um, but
which was our Star Wars program,
our
right?
Star
From the
Wars
80s.
program,
Yeah, yeah.
yes. And so that's a part of the portfolio. The technology isn't as mature as either our laser or our high power RF capabilities, but it's an area that we're going to continue to look at. Um, the How do we create beams of light, beams of energy, and what are the different technologies that we can exploit? There's a lot of research that goes on at the university levels and at our national laboratories to look at how to bring that forward, and that's all great research. The ones that I tend to focus on right now with the laser and the RF systems are a bit more mature and are a bit closer to a operational capability.
Mm-hmm.
In my lifetime in association with military, I never felt like Silicon Valley and the Department of Defense were in the same world together. I think that's changing. Do you feel that too? Do you see more of the tech leaders working closer with government, or is it not there yet?
So I will say that for my technology area, we don't have as much overlap with kind of the tech innovation because it's very different. Where I do see the collaboration is in AI and our automated capabilities. So as those automated capabilities improve, and we can take man out of the loop, like I said, man on the loop, but not in the loop. Um, that's where I think we really have the leverage, and where we're really seeing, the handover capabilities and the ability to track multiple targets, to be able to engage multiple targets in rapid succession or simultaneously, depending on which system we're talking about, and leveraging the machine learning capability, so that it comes back and says, we right now we kind of tell the system, okay, this is what we believe the target is based on our catalog of systems, and this should be your engagement point for your effector. And through machine learning, I think we can say, okay, we're picking up other piece parts, maybe other targeting locations, and those type of things. So I think the whole concept of AI ML that we're picking up through tech innovation through Silicon Valley and that is really going to enhance these weapons capabilities.
Yeah. So, do you think? I mean, to go a little off, but staying on it. I mean, with AI, I'm curious. Do you think AI will be a major like influence for the future of military advancements and weaponry?
Oh, absolutely.
Yeah.
Um, the as
Not
we
Terminator, not Terminator like though,
not
hopefully.
Terminator, but I mean, directed energy systems, the speed of light engagement.
Mm-hmm.
Um, as we talk about hypersonic weapons and those type of things, the speed and the time to engage the target is shrinking rapidly. And so AI has to come into that piece to help us understand and do aim point selection, aim point targeting, in anticipation of where that target's going to be. They're also not only they're very fast, but they're highly maneuverable. And so the maneuverability and our ability to adapt to the maneuverability, frame to frame to frame, as we're tracking an incoming target, is going to be something that's important for us to understand. And again, I think we leverage off of the technology innovation that's coming out of um, our our smart think tank areas.
I got one final question for you. You're talking to two Star Wars fans, right? Um, are we going to ever see blasters? Are we going to see, is there a capability to fire lasers to disable or kill soldiers on the battlefield? Is that
Yeah,
in our lifetime?
the laser limit we could reach one day. Who knows?
So the laser systems that we saw, with blasters and phasers and those kind of things, Star Wars and Star Trek, no, you won't see those in the near term.
Mhm.
And it's just because the power required to create that effect is really, really high, and packaging that into something that is handheld is
Yeah.
probably a bridge too far. To create those kind of effects. Now, I will say that we do not develop laser weapon systems for counter personnel capabilities within the U.S. military. There are protocols that protect the sailors and soldiers from intentional blinding. There are the anti-personnel. We do a lot of research in this area. It's a really hard challenge, a really hard problem, and there are international conventions against undue suffering and pain, intentional blinding, all those type of things. So our laser weapon systems are all counter material. And we have RF systems that can be used for counter personnel. They dissuade you from staying in the beam. And we have one that is actively engaged, created at the Air Force Research Lab and transitioned to the United States Marines Warfighting Lab, called active denial, and it's a heat beam.
Hmm.
And basically, you don't want to be in the heat beam. It dissuades you from being in the heat beam, and you move away. And I personally believe that, I should have one of those systems on the top of every one of our embassies across the world. When people are not being pleasant with the United States at our embassies, there are ways we can dissuade them other than using bullets and bombs.
Hmm.
Non-lethal ways that we can dissuade them from um, migrating, or hanging out around the front gates.
Well, Mark, Nick, and I can't thank you enough. It's so insightful, and
Learned a lot.
listen. We encourage you keep pushing on your directed energy weaponry. It's going to make a huge difference, and it is already, right?
Well, we think
Yeah.
it's making a difference now. We want to see it make a bigger difference in the future. And I've invested a good number of years in pushing this technology forward, and we're on the cusp of seeing it fully integrated into at least the U.S. military's warfighting capabilities, as well as many of our allies.
Yeah, we'll have to have him back, Nick, as the as the
He said
technology
5 years. He said
historian.
5 years, and we're still doing this in 5 years. We,
In 5 years, we're going to have systems spread out through all of our services, defending our
Right.
wow.
locations.
Well, thank you again. We appreciate it.
It's good to see you guys.
Yeah.
Good to see you too.